Hello friends, welcome to this presentation where we are trying to understand what the stretch is all about, that is under transformation. Alright, now by definition we are saying a stretch is a transformation in which points move perpendicular. So the key word here is perpendicular to the invariant line. Alright? Now, what is an invariant line? We are saying an invariant line is a line that is fixed. The line that is the line whose coordinates are not changing, in short. Alright? So we are saying when you are dealing with a stretch, it is a transformation in which points move perpendicular to the invariant line in such a way that, or in such a manner that, the ratio of distance of the image from the invariant line to that of its object from the invariant line is constant, meaning that it is the same. Right? So a stretch is like a pool. Alright? It's like a pool, isn't it? Now, the size by which an object is pulled is referred to as a stretchy factor. Okay? It is referred to as a stretchy factor. Okay? Denoted by K. Now, how do you find the stretch factor? We are saying to get the stretch factor, you're going to say distance from the image to the invariant line divided by the distance from the object to the invariant line. So you need to know the invariant line. Find the distance of the image from the invariant line, the distance of the object to the invariant line. That is your scale factor. Alternatively, we can say, maybe we start with this part. Alternatively, we can say scale factor is the area of the image divided by the area of the object. So if the image is a triangle, the object is a triangle, then you're going to say area of a triangle divided by the area of the triangle. That is your stretch factor. All right? Now, how do you describe? There are times where we give you to say you have got this object and the image. Describe the transformation that has taken place. If you know that it is a stretch, all right? How do you describe? You need to acknowledge that it is a stretch. 1, 2. You need to state. So we are saying stretch is fully described by stating the invariant line and the stretch factor. So two things that are cardinal here. You state the invariant line, the line that is whose coordinates are fixed, right, or unchanged, and the stretchy factor. All right? Okay, so this is what we are going to do here. So the next thing is we need to know how to find the image, right? How to find the image from the invariant line and stretch factor. All right? How do we get this? Okay, so given the invariant line and the stretch factor, how do we then find the image? Okay, that is our interest. That's our interest. Okay, so we are going to look at an example. Okay, let me just pick the question. Okay, so this is the question that we are dealing with. Okay, so that's a question. You can copy. All right, so we are saying a scale that we are going to use here is 1 centimeter to 1 unit on each axis. So we draw the axis from negative 8 to positive 10 for x, negative 8 to positive 10 for y. Okay, all right, so this is what we are going to do. I'll get my graph paper. Usually this is the graph paper that you are going to have in an exam. So here you put your exam number, then you demarcate your graph paper. Okay. Okay, so we are saying the scale here is 1 centimeter to 1 unit on each axis, which is the same as 2 to 2. Okay, so like we have been saying, when you measure here from as you are able to see, from this point to that point is 2 centimeters. So here you are going to have 0, here it will be 2. In between here you have 1. All right, well, it's 1 to 1, so it means this is 4, this is 6, this is 8, and this is 10. This is x. Okay, so this is negative 2, negative 4, negative 6, negative 8. I think it's okay, we can go up to 8. Then here we have 2, 4, this is 6, 8, we have 10 here. Okay, let me bring it down the graph paper. 10, 12, we go all the way up to 14 because we need to cut for 13. So we can come down here, negative 2, 4, negative 6, negative 8. I think we are good to go. So what points are we plotting? You can see the first one is 1, 2. All right, first one is 1, 2. 1, 2, B is 4, 3, C is 3, 1. Okay, so we can plot the first one. First one is 1, 2. So this is 1, 2, 3, 4, 5, which is 1. All right, 2 is somewhere. So you can even count from here. 2, 3, 4, 5 here. So it means here it is 1, 2. So you put your A here. Okay, you put your A there. Okay, you put your A there. Then we have the next one, that is 4, 3. So this is 4, x is 4, y is 3. So this is 2. 1, 2, 3, 4, 5. So 3 is here. This is our B. Okay. Then the next one is 3, 1. Okay. I think I showed you. You can even write them down so that you are following as I. So 3, 1. Okay. So x is 3. So this is 2, 1, 2, 3, 4, 5. All right. 1, 2, 3, 4, 5 is here. So 3, 1. All right. So from here say 1, 2, 3, 4, 5. So this is where C is supposed to be. Then you get your ruler and join. You don't need to take a lot of time. Okay, so yeah, so that's that. So this is the triangle we're talking about, and we've been told that this is triangle Y, so you name it as triangle Y. So you say this is triangle Y. Okay, now we are saying triangle Y is mapped onto triangle Y1 by a stretch. Okay, so it is by a what? A stretch. Remember we said by stretch means the movements of points are perpendicular to the invariant line. So we must be given the invariant line. So I've been told that the invariant line is y is equal to 0. Now, what is y is equal to 0? Take note that when you are dealing with the y-axis, this is the y-axis. Y-axis, its equation is x is equal to 0. Right? Then the x-axis, in terms of an equation, its equation is y is equal to 0. So here you have been given that the invariant line is the y-axis, meaning that the y is equal to 0, meaning that we are dealing with the x-axis is our invariant line. Alright? So it means the pull or the stretch should be perpendicular. So in this case, it can either go upwards or downwards depending on the scale factor given. Because it must move perpendicular to the x-axis, or from here it has to be perpendicular to the x-axis. But the invariant line is the x-axis. Alright? Then, so we need the invariant line as well as the stretch factor. So what are they saying? The stretch factor is 4. We have been given k to be what? 4. Take note, this is positive. Alright? It is positive. Alright? It simply means we are saying to stretch it, we must move perpendicular to the invariant line. So it will either go upwards or downwards. But how do you tell? You use the stretch factor. Our stretch factor is positive, meaning that our movements will be perpendicular to the x-axis, but it will go upwards because it is positive. If it was negative, it would have come downwards. So the pull would have been coming downwards. So now, what you do here to make your job easy, let me rewrite these coordinates, okay? Okay, so these are the coordinates that we have. So now we must find the image. What is our invariant line? The invariant line is the x-axis. It simply means these coordinates of x should be maintained. So you have got 1, comma, we need to find y there. So b1 will be 4, comma, we need to find y there. Then c1 will be 3, comma, we don't know the value of y. Because x-axis is the invariant line, so these values of x will be maintained. Okay? But what is our scale factor? Our scale factor is 4. So it means it is only the coordinates of y that will change. How are you going to do it? You can easily multiply 4 by these values of y, or coordinates of y. So you're going to say, what is 4 by 2? It is 8. So here we have 8. What is 4 by 3? You have 12. What is 4 by 1? You have 4. So these are the coordinates for the image. And you plot. Alright? You plot. So the first one is 1,8. 1,8. Alright? So x is 1, y is 8, somewhere here. So you're going to say 1, 2, 3, 4, 5. This is what you're supposed to have. Then B1 is supposed to be, so here we can say A1 or A image. Alright? Then we deal with it. This is A1. B1 is 4,12. 4,12. Alright? X is 4, y is 12 here. In other words, the distance of B1 from the invariant line should be 12. Alright? Then C1 is 3,4. 3,4. So 4 is here. This is like 2 when you check the x-axis here. When you check the x-axis here, this is 2. So you have got 1, 2, 3, 4, 5. So this is where C1 is. Then you connect. Okay? Okay, so when joining, after joining, this is what you are going to get. And we have been told that this is the y1. So you are going to say y1. Okay? So if you want, you can even write your answers. Say for A, because we're dealing with A, it is triangle y. Okay? For B, we are going to B now. What is B? Let's take note of B. B, we are saying triangle y is mapped onto y2 by stretch. So again here we are saying it is by what? Stretch. So we know if we're dealing with stretch, we need to think of the invariant line and the stretch factor. Okay? Now what is the invariant line? The invariant line, we have been told that it is x is equal to 0. If it is x is equal to 0, we are dealing with the y-axis. Alright, we are dealing with the y-axis. And what is our stretch factor? The stretch factor is negative 2. Alright, so what that means is that if the invariant line is the y-axis, then the values of y will not change. Alright, so let me rewrite the coordinates again. Because this is what we have. So we have got the A2 now, because we are dealing with the y2, so the coordinates should be A1, A2, B2, 3, 2, C2. Alright? So here we are saying the invariant line is the what? The y-axis, meaning that what will change is x, y will remain the same. Alright? So B2 here, what will change here again is x, y will remain the same. Alright? Here, C3, C2, y will remain the same. Alright? What will change here is the x. But how are we going to get those coordinates of the x-axis? Okay? Or what will be the coordinates of the x-axis? We are going to multiply the stretch factor by these coordinates of x. So we are going to say 1 by negative 2, you have negative 2. Alright? 2 by 4, you have negative 8. 2 by 3, you have negative 6. So we're going to use these to plot. Okay? Then that's how you get those things. Alright? So that's how you get those things. So we come to we plot using these. Okay. So negative 2, we have negative 2 comma 2, which is this one. So you have your take note, we are saying this is the A2, so we have A2 here. Alright? Then negative 8 comma 3. Negative 8 is here, comma 3. This is 2, 1, 2, 3, 4, 5. This is what you are going to have. So this one will be B2. Okay. Then negative 6 comma 1. Negative 6 comma 1. 1, 2, 3, 4, 5. This is the C2. Then you join this point to that, create a triangle. Okay, so this is a triangle. So take note, the stretch factor was a negative, so it means the pull will be towards the left hand side. If it was positive, then you would have taken it to the other side. Basically, that is how you are going to draw that triangle. And we need to indicate that this is the y, triangle y2. So for B, you are going to say it is triangle this is 1, this is triangle y2. Okay, then we go to C. I hope you have the questions. Yeah, you've already copied. Let's see C. All right, we are saying triangle y is mapped onto y3, so we have triangle y3. All right, by a stretch. We know again we are dealing with a what? A stretch. Okay, what is the invariant line? Invariant line is x is equal to 0. X is equal to 0. So meaning that the invariant line is the what? The y-axis. Take note, it is the y-axis. So the values of y are the ones that are not changing. Alright? Okay, given that B3 is equal to 8 comma 3. Now let's find the stretch factor and the coordinates of A3 and the C3. Okay, where possible, we can even draw it, but I think there is no need. We have not been asked to do that. So look, you have got B3 here, so you must compare B3 to B, because it is this y that is mapped onto y3. So what are the coordinates for B? The coordinates for B are 3 comma what? no 4 comma 1. All right, no, take note, it is 4 comma 3. So let me write nicely. B3, we've been told that B3 is 8 comma 3. All right, but the coordinates of B are 4 comma 3, and since we said the y-axis is the variant line, okay, that is why here the coordinates of y are maintained. All right, now you've seen that this is 8 and this is 4, right? So the question is, what is the stretch factor? You just divide 8 by 4. All right, so you're going to say 8 by 4, and the answer is what? 2. All right, it is positive. So our stretch factor there is 2. All right, our stretch factor there is 2. So for C1, we are saying our C Roman numeral 1, our K is equal to 8 divided by 4, and the answer is 2. You do that. It's very simple arithmetic. All right. So the next one is, let's get the coordinates of what? A3. So I'm going to say A3. What are the coordinates? So for us to find the coordinates of A3, we'll say, for A3, what are the coordinates of A? All right. So if you look at the coordinates of A, what are the coordinates of A? 1 comma 2. All right. And what is our scale factor now? It is 2. We found 2. All right. But we are saying y-axis is the invariant line. It means here the 2 should be maintained here. Okay. What we change is x. And what are we going to do? You say 2 by 1. All right. 2 by 1, which is 2. Okay. Then to find the coordinates of C3, again we'll say C3 is equal to, then I have to find the coordinates of C first. What are the coordinates of C? 3 comma 1. But we are saying a variant line is the y-axis. So meaning that here 1 will be maintained because that is the value of y. All right. So for us to find now the value of x here, you're going to say the scale factor by 2, which is 6. So these are the coordinates for A3, 2 comma 2, 2 comma 2, then C3 is 6 comma 1. Okay, 6 comma 1. So you have, I want you to see nicely, 1 comma 2, 1 comma 2, and C3 is 6 comma 1, 6 comma 1. So that's how we are supposed to do it. We were not asked to draw it, but if you wanted, or if you want, you can still draw it. Then we go to the last one, which is D. Okay, what is D? We are saying triangle Y4 has these vertices. Okay, so we are saying Y4, triangle Y4 has these coordinates. A4 is 1 comma negative 4. B4 is 4 comma negative 6. C4 is 3 comma negative 2. The question is, describe fully the single transformation that maps Y onto Y4. Okay, so sometimes to make your job easy, you can plot these. All right, plot and see the kind of the transformation that is there first. Okay, so plot. So you have the first one, negative 1 comma negative 4, which is somewhere here. So say 1, 2, 3, 4, 5, which is this one. Okay, This is the A4. Then the other one is 4, -6. 4 here, -6 to come down here. This is the B4. Then the other one is 3, -2. So should be, this is 2 and this is 3, so 3 should be somewhere there and -2. So you can even start from here because this is -2. 1, 2, 3, 4, 5. This is what you're going to have. This is C4. Then connect. Okay, so that's what you're going to have. Then you're going to, this is Y4. So the question is telling us now, so we can see that from this diagram to this diagram, there's a pull here, all right? It is a stretch downwards. It is a stretch downwards. So you know that it is a stretch. So you must write that when describing, you say it is stretch, all right? But for you to describe stretch food, you need to give the invariant line, all right? But you can see that here you are pulling it downwards along the y-axis, which is perpendicular to the x-axis. So the invariant line here is the x-axis. Or alternatively, you can say, let me get the coordinates of triangle y. Okay, I compare. What are the coordinates of triangle y? Okay, look. The coordinates of triangle y. 1, 2. So 1 is maintained here. 4, 3. 4 is maintained here. 3, 1. 3 is maintained. So it means x-axis is invariant, is fixed, all right? Or you can say this is the y is equal to 0. Okay, that is y is equal to 0. Then what is the stretch factor? So for us to find the stretch factor, we are going to look at maybe just one point, this point and this one. Okay, so it is the image from this definition. Image divided by the object. So what is our image? -4. What is our object? 2. All right, this into that is -2. That is why the pull is downwards here. That's why the stretch is downwards, because it is negative. So it means our invariant line, take note, line is x-axis, right? Then k is -4/2, which is -2. So that is how you find the image given the object, given the invariant line and the stretchy factor. All right, so thank you so much. I hope you have liked my presentation. Please subscribe and share with your friends. Okay, so I'll give you an exercise that you can attempt. Please try to take about 10 minutes or so. Okay, so that's the question. You can attempt it. Okay, thanks so much.